Hi everyone. So we're going to do developer office hours today, and we're going to look at private voting. I think we're still waiting for Will from our BD department to say hi, and we're going to talk about private voting and what can we do with Sapphire. How's it different from what we usually expect on with DAOs and the sort of voting process we have, and how does it relate to the real world as well? So I think Will, maybe you can start us off with just a quick intro about like Sapphire generally and how it relates to voting.
Yeah. So I guess in general, like Sapphire works like any normal EVM. So it has all the same functionality that a normal EVM would have for voting. And I think DAOs over the last sort of market cycle have become very prominent. So it has the ability to have like coordination and normal voting and sort of the normal governance process. So the editability though would be the confidential state that Sapphire offers. So
So that means that we could have like votes that are private, or we can keep the tally private while it's in progress, or we can hide the voters, or we could even hide what people are voting on from the rest of the world.
that's I mean there's two like or no I guess what I would like to say is I think that confidential voting has been like a missing feature. And people have tried to do it with like shielded voting using like threshold signatures in the past, which is a great solution and added a lot of functionality to DAOs, but it lacks customizability in the sense that it allows you to hide the vote while it's in progress, but it doesn't allow you to hide the vote indiscriminately for ever or like 100,000 blocks after the vote's concluded. It doesn't give you
Yeah.
this sort of customizability, um, and so I think at least the way that I think about what we're trying to do with Sapphire and what Web3 in general is trying to do is they're trying to compete with Web2. And in order to do that,
Hmm.
you need to have as much sophistication as Web2, and you need the same level of user experience. And so, what Sapphire really enables, not just for voting, but for anything, is the ability to build more sophisticated, more complex, and smart contracts that also offer better user experiences. And so that's
Yeah. So if we look at like voting in the real world, if we have like local elections or government elections, and we expect that the votes are going to be private, right? And like over the past like couple of hundred years, I'm not really familiar with like the history of voting and that kind of stuff. But it's been decided that okay, we do need to keep the votes private. So I know in a lot of states there are laws around you can't give gifts out to people who are standing in line to vote, right? But Web3 is, well, one, we've started off with everything's transparent. So this is a complete fundamental shift away where like you're seeing incentivized voting on Web3, which seems like the diametric opposite of what we have in the real world, where like like should we incentivize people to vote on stuff? Should we just accept and price in collusion and bribery into this, or should we try to find something that's um, that's closer to like what we have in the real world, or even are there different things that are going to come out when you have like flexible privacy options? Like, is there like a different kind of dynamic that we could play with now that you can decide sort of what is and what isn't private, or that kind of thing?
So I mean, in terms of I mean, the way I've talked about it in the past is we shouldn't like throw away, I don't know, the 2,000 years more of like our human lessons that we should, aim to have confidential elections and confidential governance and voting processes. I mean, I think it's probably been time tested, and there's a reason why we want um, to have these confidential governances in the U.S. Even like at least when I remember back to high school, we learned about times in like the 1920s when there was rampant corruption and like vote buying and stuff like that. Um, I think. the bribery inclusion is one aspect. The other aspect is like just like sort of reputation. So you can imagine um, potentially like I don't know, maybe it's a small vote, right? It's 13 members of the board of a DAO, right? And one person is the CEO and kind of leading things, and he wants to vote one way. The rest of the board might feel uncomfortable publicly disclosing that they're opposing, the leader, and that's not great for like decentralized processes, which is what we're trying to do. And then the other aspect is like bias, right? So there's interesting phenomena where people sort of who maybe are not following a voting governance and maybe are not like up to speed on what's going on with the DAO. They might just look at the voting dashboard and then see that one side is winning, or see that one of their friends have voted in one way, or see that the prominent figure like Vitalik or Stani and Aave have voted in a particular way, and then they'll just follow in their footsteps without actually adding like much critical thought. And I think like all of these things are what we're trying to remove with confidential voting.
So that's like the sort of herd mentality of instead of it being a the fifth, like first past the post, like 50% majority, it's, well, if anybody gets, if what party A gets a 3% majority and party B is still at 1%, then because everyone sees that party B is in the lead, they're not thinking, they just go ahead and vote, and having private voting there is really important to prevent that.
Yeah, so I think that sort of bias can potentially be mitigated with just the shielded voting. The reputational stuff, though, that can't be mitigated with shielded voting. And the one where basically you can hide the voting while it's active, but once the vote actually happens and the governance needs to change, the vote has to be posted on chain. And so that's what I really think about like Oasis Sapphire, is it offers all this flexibility for DAOs. And in general, like I think that's what any sort of network or any sort of tooling in Web3 should be trying to offer, like as much flexibility and sort of expansion of the what use cases are possible. And I think that's really what initially got me excited about Oasis, and it's what started my career here. And I think the confidential voting is probably one of the use cases that demonstrates the best, is that we really have just expanded what is possible.
Yeah. So if you look at if you want to do development on Sapphire in comparison to like ZK or sort of threshold signature schemes, or even like multi-party computation, it's like there are companies out there whose entire sort of thing is, okay, we allow shielded votes, and this is like, for me, this is like a weekend hackathon project of like, okay, cool, like I wrote that in Solidity, in a weekend. Okay, what next? Let's so in terms of like acceleration of development versus those other schemes.
Right. So it's a weekend hackathon project on Sapphire, but if you're using threshold secret sharing in order to do it, it's actually probably a multi-year long development effort. And yeah, so again, like you said, it's Sapphire not only allows the flexibility, but it also offers I don't know if robust is the right word, but like an amazing developer experience, in the sense that you get to code in Solidity and it just works the way that you expect it to work on any other EVM. It doesn't involve any new cryptography. You can just be a programmer who's passionate about the Web3 space, and you can deploy something. And it doesn't have to be shielded voting. I know that that's just what we're talking about today, but other interesting use cases were like the sealed bid auction that NFT announced earlier today. This is something that's not possible. There was super degraded user experiences, including gas congestion, poor price discovery, users paying thousands of dollars in gas and then not even getting the NFT because someone front ran them in a mempool, people just front running in general. All of these things have been solved by sealed bid auctions, and it was able to be deployed in 3 weeks using Sapphire Whereas, as far as I'm concerned, it would take months, if not almost a year, to build it with using like zero knowledge, and it wouldn't even be as flexible or as robust as what was done on Sapphire. So I know the focus today is confidential voting, but I just want to throw that out there that it's not, it's not the only use case. It's really applicable. These things that we're talking about with the use cases for confidential voting are applicable to pretty much any use case or any vertical in Web3 that you can think of.
So yeah, I think one thing I want to bring up really quickly is so if you do go down the ZK route or some kind of threshold signature scheme, like from the very start, you have to have a specific idea of exactly what you're going to do, like exactly you have a one model that fits everybody, or is supposed to fit everybody. But what I like about Sapphire is, okay, just like with DeFi and composability on Ethereum, I could have DeFi and composability, well, not DeFi, but I can have like VoteFi or whatever you want to call it, right? So I can have different pluggable modules. I can have on a poll by poll basis, for example, I could have like a different set of configurations for this poll and a different set of configurations for that poll. Or I could even do like silly things like, okay, there's I'm going to put a price on revealing who voted for what, or that kind of thing. I think what would be interesting is looking at like the dynamics that having options and having programmability can add to voting that we might not have discovered so far.
Yeah, I mean, you can think of it as outside of governance, something like SurveyMonkey, right? So Oasis sort of started off as this like a data marketplace idea, or like it was maybe one of the first use cases that were thought about when we were talking about Parcel back then. And we have products right now like Delta DAO and a few others that are looking into like the data marketplace type ideas. And so like, it cannot just be like for voting, but it can be for polls. And then you can think about like, I filled out this poll a certain way, but like, and this maybe is useful to an advertiser, but maybe I can share other data about myself and what I filled out about my poll that gives more targeted insight. And now you're able to sell your data, or like you can reveal specifically how just you filled out your poll. Things like that are, again, like, it's pretty much just a few modifications, maybe more than a few, but it's relatively easy to build, at least when you compare it to like modifying a voting contract from ZK to do something that we just discussed. I'm not even sure it would be possible because there's no really like state being saved, at least like in current ZK models. But even if it was possible, it would again be like a multi-year endeavor, whereas this could be done maybe not in 3 weeks, maybe a couple months on Sapphire. You'd probably know better than me what the timeframes are, but yeah, these are the flexible.
The development always takes longer than expected. I think that's the key thing. Like I can hack together something in a couple of days, and it generally works. But then taking that from like a little idea to something else is a lot of effort. So this is where with ZK products you have a huge overhead because you can't like plug and play, right? You can't sort of mix and match. So you have to take your thing and bring it to build all of the websites, the sort of interface, the UI for that. But I think what I'd like to see with DAOs and privacy and voting and with the customizability is like more pluggability. So having different ways of controlling what is and what isn't revealed, having different ways of controlling who can and can't vote. And I think like there's two models I'm looking at the moment of where we haven't possibly fully explored those. One is like delegated voting with privacy. Can you have like a private pool of delegates that you don't know who they are, but you can see their history and how they voted, so that that if I delegate my vote to these people, they're going to, it's a political representative, right? You would like, even if the members of Congress were fully anonymous, their entire voting history is open. And maybe they need to be anonymous in order to make the best decision, because that's how you can get the ego out of it.
Yeah, I mean, well, I would say that's exactly following Congress, right? Like Congress's votes, how Ron Paul or Elizabeth Warren or Nancy Pelosi vote is always public, but you don't get to see who delegated or who voted for them in the primary elections. And so it's in my opinion, it's mimicking the governance processes that we have today, which I think goes right back into what I was saying. Like our goal in Web3 is to make Web3 as sophisticated and as user-friendly as Web2 or traditional finance or traditional governance. And at that point, that's when we really take over the landscape. And so this would be a great example of, we just thought of a model, or maybe not just thought of a model, but we just gave an example of a model where now you have basically recreated what's possible in Web 2 in Web 3, which previously was not possible before Sapphire, or at least, extremely, extremely, extremely difficult before Sapphire.
What about like things like I don't know. I try to find a word for it. It's like an anonymous zeitgeist, anarchic DAO, right? It's questions for the sake of questions, and eventually those end up, deciding what's happening. So it's like, what if you can't see the questions until you share your opinion on another question, and you can only share your opinion if you're a member of one of these different DAOs. So it's like, think of the inner circle of like, we got a spicy opinion poll of a temperature check of all of the core developers who are in any of these DAOs, right?
Yeah, so it's like sort of like gatekeeping a DAO based off of your previous voting history, making sure that you're aligned with at least the current DAO, and then shaping it from that point forward, something along those lines. I think that's what you're talking about.
I'm not sure. I'm just trying to think of like in 5 years time, what more voting options will we have? Like, will it turn into a thing of its own where you're not sure who's running the DAO? Not sure. You might stumble across by filling in some polls or on being a member of this DAO. You might stumble across, oh, actually, I'm now a member of the Uber Meta DAO or something, and I didn't know it existed until now, right?
Yeah, that's I guess, I guess right now that's like somewhat difficult to think about like what the architecture would look like. But yeah, I think these are the type of things that are possible. And constantly what's being done in Web3 is taking the primitives once they're possible, once they're enabled, and building things that are like super unique. I don't know, Flash loans comes to mind of like something that was built in Web3 it's not even possible in Web2. And so yeah, I would say that that's a very interesting idea. I still would struggle like how, if you have private voting, how that the Uber Meta DAO would know who to let in. But perhaps it's like, you sign off on allowing just smart contracts, not people, but smart contracts to know what your voting history is, and then it can assign, what DAOs you would fit in most with, or something like that. And then like the sort of other thing, that maybe talking point that I'd like to add here. I know we're sort of talking a lot about other technologies like FHE, MBC, and ZK, but again, these are like things that it's not even a question of how difficult it is to build. It's like a question of like what is actually possible with those technologies, because everything we just talked about requires like sort of the computing on the data from many, many people in many different instances, which Sapphire does fairly easily, because inside the black box, it runs like a normal EVM. So it's just as composable. But in other sort of frameworks, it's not so easy to run, I guess, what we would normally call like a multi-party computation on private data.
So I think, just out of curiosity, like, do you think that if you look at like traditional business at the moment, like, are DAOs, are they going in the right direction to be useful? Like, if I look at the sort of, being on the board of directors, or like internal processes, like the grants and approvals and things like that. I still think there's a huge disconnect between like normal business, where you expect some kind of confidentiality, and this like Web3 world where people may be anonymous, they might not be anonymous, and I think there's a huge like gap missing with DAOs, where it's just not suitable at the moment.
Yeah, I would say like right now, is it going in the right direction? Yes, but but there's like you said, there's gaps. Like notably, like Aragon has just done a lot of work on like DAOs within DAOs. I think this is super necessary. Like I don't think you need every member of a DAO voting on every proposal. It becomes difficult to reach quorum. It becomes expensive for every user to sort of get involved with every governance process. Like let's say you're voting on like marketing budget, right? Or like you maybe don't need every member of the DAO voting on like whether you should spend $1,000 on marketing at some event at a conference or something like that. That's just like one example. I also think there needs to be like separation and synthetics did something similar to this, and I think more DAOs probably have as well. But it needs to be like more ubiquitous. Is like to have like councils, so voting in councils, and then some decisions, sort of laying out what decisions the council can just vote on between themselves, and which sort of decisions have to be voted on by the entire DAO. But like, basically right now I see a major problem with basically how fast DAOs are able to move. And in fact, a lot of people are not going the DAO route until like they've reached like critical mass because it slows down sort of progress by such a large amount. So these types of things, DAOs within DAOs, councils, delegations, those are like the major areas, and that we are working on them, and the industry is going in the right direction in those areas. But I think a lot of progress can still be made. And then I do have to hop off in 1 minute, but the other area.
Yeah, you have to go really soon, so I'll let you.
Yeah, the confidential voting aspect, I think, in terms of the industry, obviously we're working on it. I think Aztec and Nouns DAO are working on it. But I do think that more weight has to be put on confidential voting for DAOs. Ari Jules, Andrew Miller, and some other very prominent cryptographers in the research space recently published a paper on what's needed to make DAOs more decentralized. And I think the number one, at least like maybe not in order, but they list key points, and the one that's in the first bullet point is confidential voting is necessary to reduce bias and make DAOs more decentralized. But at the same time, I don't know if DAOs are focusing on that. And I think maybe it's just because they don't even know these technologies exist. Maybe it's, they got a lot of other things to work on that they thought were easier. But now with Sapphire, I think it has become sufficiently easy that DAOs should be, at least taking a serious look at whether this is something they want to implement.
Yeah, I mean, I hope things are going to move faster and quick in the future. So you've got to head off in a second. But I think something I really love to see is Twitter for polls for DAOs. Like, can we completely change the model? Like every DAO has its own app, and there's a bazillion different apps, and it just keeping track of like what you have to vote on to begin with is starting to become a big problem. Whereas with Reddit, Facebook, whatever, I've got a constant stream of questions I can give my opinion on.
Yeah, absolutely. And I guess what I would say is, hopefully there's developers listening right now, and hopefully some of these discussions have, inspired you. And maybe you have something really creative that you can work on, to help with some of these problems we've listed, and take, sort of the DAO landscape in Web3 to the next level. Anyway, guys, I have to hop off, but thank you for having me. I hope this discussion has been,
thank you very much, Will, and I'll let you get on with your day.
Right, so have a great day, everybody. Bye-bye.
Bye-bye. So I think now we're going to switch over to a bunch of slides that I did in Denver, where we're looking at like a private sidekick for DAOs. So based on like some of the ideas that we've been talking about today, like what is a private sidekick? Well, think of like ad hoc unofficial opinion polls for DAO members. So we were talking about like moving quickly and moving slowly, and a lot of DAOs there is this like inertia that's there. So if you wanted to add private voting, you'd have to get a poll, get a proposal, submit the proposal to the DAO, get people to vote on the proposal to enable private voting in the DAO, and but behind the scenes, that like I say that most democracy sort of happens off chain, so it's not necessarily about the proposals, and it's talking to people in telegrams and discords in person. In the UK, a lot of democracy happens at the pub over a beer, for example. And there's also the question of, well, will privacy and anonymity, like if you're trying to gauge people's opinions, if you're trying to do temperature checks, then as Will said, like you might not want to have your name publicly attributed to that, just because that could sway people's opinions, or it could people just go along with the herd and go with whatever currently has the most number of votes, even though it, without actually considering that. So I think, like with adding privacy and anonymity, this is a good option for you to not be able to see what's going on until like the temperature check has been done. So anyway, we were looking at how do we create a little tool for DAOs that they can do these temperature checks. They can do them more frequently. They can do it faster, and hopefully, if you have like more frequent opinions where you do have like privacy, then that means that you can, you can say what you really mean in your heart, or what you really think, without being influenced by others. And hopefully that's going to end up with like better decisions overall. Especially if I can create a little poll, and I can send it to someone on Discord and say, okay, here's a poll. I won't see if you voted or not, but you have the option to vote on this. And more importantly, we only want this to be available to people who are members of an actual DAO. So you don't want everyone's opinion. You want a very select number of people's opinion. So So I'm going to dig into some details and try to go through the tech behind this. But what's it look like? So we created a voting demo last year in East Denver, and over the past 6 months or so, we have tried to figure out, okay, so hey, how can we do this? How can we make it easier, quicker to create these polls? And one of the things we avoided was integrating with all of these DAO platforms. So if you want to add private voting to Aragon and get it like in their platform, or add it to DAO House or Tally or Snapshot, it's quite a long, drawn out process where you have to add explicit support to all of the different DAO providers. So instead, we said, okay, let's create this, extend this demo a bit, and how do we access control who's allowed to vote on this? So one is the question of access control. So on a poll by poll basis, when we're creating the poll, we can say, okay, I want to have the access control set to cross-chain DAO. Then I set my network, which my DAO exists on. I set the address of the token. So this works with ERC20 tokens. It works with ERC71s and NFTs, where you can say, okay, so anyone who holds any number of NFTs, they can vote on this. And then, of course, because of the way we're doing it, so we don't actually verify if the like the block hash exists, right? So we're doing all of the validation so we're not doing all of the validation in the client side, but so the contract is enforcing the block header proofs, and we're saying that if you have if we specify the block hash in a poll, then anyone who can provide a proof that they hold a balance of this specific token at essentially at a snapshot, a point in time, then they're allowed to vote on that. And so we've gone through a couple of different things about like why privacy, and what needs to be private. Why does it need to be private? Like, and one size doesn't necessarily fit everyone. So in terms of being private, if you're looking at on-chain analytics of looking, if you know the address of the poll, and you can see people voting. You can kind of, if you know people's addresses, you can look up the different people who voted and who paid gas for the transaction, and you can kind of figure out like who they are. And you might even learn a lot about the participants of a DAO just because you can see their whole transparent sort of blockchain history on chain. So what needs to be private? One of those is who's voting. You know, like if you're paying gas to vote, then your account has a transaction that pays gas that interacts with a private voting contract. So even if you don't know who I'm voting on, you do know everyone that's voting on this. And why does it need to be private? Well, we've gone through this earlier. I think it's not that why does it need to be private? It's that being able to choose what is and what isn't private on a sort of a poll by poll basis. This adds a really, really interesting dynamic. And one of those is anonymity. So maybe if everything's configurable, you have you want to know that certain people did vote, but you don't know what they voted for. So you know that, oh, out of the 10 different people that are members, you know that 9 of them did vote and 1 didn't vote because they're on holiday, or you know that they were ill or something like that and they couldn't get to the computer. And then so you know that they did vote, and then the tally that comes up would be, well, this is their sort of collective idea of what their opinion is. And the main thing I'm getting at is that we need a little bit of configurability. So we need to have these different options. And with ZK and threshold signatures and multi-party computation systems, this is really, really, really difficult. But with Sapphire, just like with DeFi on Ethereum, you can have composability. So you can create plugins. You can have, say, different access control plugins, or you could fairly easily modify it to do something completely different. And it's really up to you to figure out what you do need on a case by case basis. But we're exploring the different options that can be configurable, and we're trying to make them accessible. So I'll get into the demo in a second, but this is a very quick example of so which country makes the best butter. Of course, this person says France does, and I'm not a particularly great UI developer, so I've just added a bunch of information at the bottom here, which is only holders of a specific cross-chain token may vote on this poll. So you have like the address of the token, the chain ID, the slot. So that's the storage slot with that's used for the mapping of the address to the token balance. And then you have the snapshot block. And then of course you submit your vote. It verifies that you hold that specific token at that specific time. And then after the poll is closed, you can see that apparently France makes the best butter. So yeah, we're still working on the UI, but the gist behind it is everything is configurable. So how does it work, right? So we have our little anon person here who, with Sapphire, you have encrypted transactions. So they submit an encrypted transaction to the private polling contract, which says, I want to set my vote on this poll to option 2. The private polling contract will query like the token weight access control list or access control contract. And what that's doing is it's using your token balance from where you provide the proof from. So you fetch the proof from the Ethereum RPC endpoint for your storage slot on that account. You provide that to the token ACL, which verifies the storage proof. And it uses, block header caching and account caching to do that, which means that there's no direct link between the confidential voting on Oasis Sapphire and the DAO on the home chain. So that means you don't have to explicitly allow confidential voting on the home chain or integrate it with the DAO. And but you know that whoever voted privately and anonymously was definitely a member that definitely held that governance token. Because we're verifying the the signature that's created by the MetaMask browser extension. So this is definitely my account that I signed from, for example. So I'm going to go very quickly through how the access control works. So I said that each poll can have a different access control contract. And essentially, it's a contract that's deployed that you specify the which access control contract you want to use when you create the poll. So we have two important things here. We have on poll created. So that's where the poll manager notifies the access control contract, and it says, hey, I've just created a poll. So here's the new poll ID, and then here's the data that was passed along by the poll creator. So in this case, we've got the poll manager is going to be message sender there. So when you're creating the poll, you can specify different initialization options. So if we go back here, you have these are the initialization options. You have like the token address, the chain ID, the storage slot, and the snapshot block. And then when the poll is created, when people want to vote on that, it double checks when they're submitting their vote, can this person vote on the poll? So you've got the poll manager and the poll ID. Then you've got the user who signed the voting request, and then you've got some auxiliary data. So in the case of the storage proofs, the auxiliary data here, that would be the storage proof that you retrieve from the Ethereum RPC that shows that this specific storage slot has a certain value at this point in time. And more importantly, that function returns the voting weight. So if you're looking at like flexibility for access control, you could have different policies here. So you could have the vote weight, you could return 1, regardless of any number of tokens that the person holds. Or you could return a logarithm of the number of tokens they hold, and you get something getting close to quadratic voting. Or you could have different categories. So think of like if you have different classes of shares, you can have multiple classes of voting shares where if we have these are individual people, you could have, oh, this person's opinion is worth 10 because they've held these tokens for more than 3 years, whereas this person is 3 because they've only held them for 6 months. And having this sort of configurable plugin based system means that you can decide on a sort of a case-by-case basis what you want to do, and it's configurable. So yeah, I think I'm going to get into some code very quickly, but the main thing here is that we're not using a cross-chain bridge. So in the user interface, we put in the block header, and it's up to the client to verify that this is a legitimate block header. This is for a specific token I do hold, so which means that it's for opinions only. So while it does use like Intel SGX, which is much easier than ZK and multi-party computation, because we're not using like a bridge, because with a bridge you'd have to have the extra step of porting the token, sending a message from the chain the DAO exists on, which means that we'd have to deploy a contract on every chain that you want to be able to vote from, and that just makes it really slow. It means you have to have like gas on multiple different chains. And that means that the speed and sort of flexibility that you have from being able to decide, how this works without having to integrate, without having to deploy additional contracts, that should make it better. So we do have a demo that's live at the moment, and you can go to github.com/oasisprotocol/demo voting, and I'm going to walk you through the process interactively, and then show you some of the code that comes behind this. So we have our poll manager contract here, where if I go to create a poll, do DAOs suck? Let's use that question. If we say this is the description, and we're asking a couple of questions, so like let's just say A, B, and C, and what this is doing is that when you submit your poll, this is encrypting the poll metadata. So the poll metadata is the question, the description, and the values that you've got for the answer. So because we're trying, we're doing confidential polls, you might not want this to be publicly available unless you share the link for that. So we're encrypting all of the poll metadata and we're uploading it to IPFS. Now I'm going to say I do want to subsidize the votes. So if I add in some rows here, when I'm subsidizing the vote, that means that anyone who is allowed to vote according to my access control, the contract will pay for them to vote, which means that they don't need to have tokens on Sapphire. They don't need to hold rows in order to pay gas because you have paid this for them, essentially. And the way that we're doing this is through a process called gasless voting. So if we have a very, very brief look at the code behind the scenes here, we have the gasless voting contract, which it actually holds key pairs. So it generates a key pair like an Ethereum wallet. And that means that when somebody wants to vote, they can ask the gasless voting contract. They can say, hey, here is what I was going to vote for. Can you check with the poll manager and check with the ACL for that poll? Is this, it will only sign a transaction for you if you have a valid vote and you're eligible to vote. But the gasless voting contract, it will actually sign a message for you here. So if we look at make vote transaction, so we look up we create a unique ID for this. We verify that this does exist. We check like, can the person vote on the poll? And then we verify the EIP 712 voting request. So this is it pops up in the browser, and you'll see in a minute where we're asking the person to sign their choice, the specific proposal. And then what it's doing is it's encrypting all of that information, and it's creating a transaction with encrypted information that only it can decrypt. And then it's signing the transaction where it will pay the gas to submit your encrypted information to itself. And that invokes the proxy method, which decrypts the encrypted data that only the contract can see. And then it just passes the call on to wherever it's supposed to go. So if I go through the configure the ACL now, I look at a cross-chain DAO. So I want to use, because my DAO's on the Polygon Mumbai testnet, and the token I've got my DAO here, and I've got my token here. So if I put in the address of the token, it does say a second. So there it's go, oh, this is an ERC20 token. If I then look at my holder, so I've got my one of the example holders that I use, and behind the scenes, the reason it needs a holder is because it doesn't know if like the balance is correct or not. So what it's doing is if you give an example holder, it checks the balance of that person, and then it iterates through the different storage slots and tries to figure out which storage slot in the contract represents this person's balance. And of course, we get the block hash, that's the snapshot at a point in time. And we go and create the poll. So I do have to pay gas. And you can see that I'm subsidizing it with 5 gas, 5 rows. And then the fee on top of that for creation on my testnet is about half a test. So I do that, and it will take a few seconds for it to be created. So that's been confirmed. And now my poll's live. So I can go through and view the poll. And this is where it's not working. Huh. And this always happens with the demos, where I think that it's going to work. I tested it right before I did the live demo, live presentation, and it did work. Let's go back, and it's not loading for some reason. But you can see the previous poll that I created. This isn't working, unfortunately. So I'm probably going to have to skip through this part, and instead I will look at the access control. So I'll look at how's this implemented, and how can you create your own access control. So we've got a few minutes left, and so one of the interesting things with Sapphire is that because you have confidential storage and because you have encrypted transactions, which we call data encrypted, I can do things like I can have a password-based poll. So anybody who knows the password can vote on it. And this is really, really simple. So if in my onPoll created function here, which is called by the poll manager, the argument I put in is the password. So I just derive an ID for the poll, and I set the password. I hash the password so it's a specific size, and then in the can vote on poll function, I just check, hey, is the password correct that the person supplied when they submitted their vote? Oh, there we go. It has loaded. It just took a while. So in this case, if I switch over to a different account, so this is account here, this doesn't have any gas at all. So I've got nothing in here. And let's refresh. But this account does actually hold tokens. So it does hold my governance token. And I'm going to say option C is the option here. I submit my vote. And you can see it's not asking me to pay for gas. It's just asking me to sign this. So I say the DAO contract. I can give a name to the DAO contract in MetaMask, a proposal ID. So that's the same one that's shown in the URL bar here. And the choice ID is 2, so it's 0 index, so 012, that's C. I press sign, and behind the scenes, it has retrieved the proof of my token balance from the Polygon Mumbai RPC. It says there is a gas voting balance available, and it's constructed the transaction for me and submitted my vote. And you can see that's all without having any gas currency available in my balance. So if we look at how does this work behind the scenes? So we've got a few different ACLs. We have allow all ACL, which just says yes to everything and doesn't do anything else. Then we have the password ACL, which we've been through. We have the token holder ACL, where, for example, you can check if the balance using balance of the specific user is, we use that as the weight, but you could set a minimum. So you could say, I want people to have at least 100 of this token, in which case you return yes or no. Or we could do the storage proof. So with the storage proof ACL, we have a structure here. So the poll setting, so this is on a per poll basis. We set the block hash, the account address. So for the account address, that's the contract address. on that chain, and then you have the slot. So with the block hash, the account address, and the slot, that should be enough information to verify storage proofs taken from any Ethereum compatible chain. So as part of the poll creation process, you do have to prime it with some additional information. So from the block hash, you don't necessarily know if the contract doesn't know the block header from the block hash. So when you're creating a poll, you have to supply the block header, which this is passed in the poll creation options when you create it. So it's done behind the scenes, and you also have to prove that the contract exists within that block header. So just like when I provide a storage proof of my balance of a specific token, when I create the poll, I'm providing a proof that the contract exists within that header, and that contract includes the storage root. So the storage root is where all the information about its storage is defined as the root of the Patricia Merkle trie. So I prime the header cache, I prime the account cache, and then when I go to vote on a poll, I'm providing an RLP encoded storage proof along with my signed vote. And then that just says, hey, storage proof, verify the storage. We've got the block hash, the account address, and the slot from the settings. And then we've got the key. So in the mapping from the user to the account balance, this is the key of that mapping. And then we have the proof. And that returns the value of that piece of storage there. So behind the scenes, it's really simple. We look at the account hash there, and then we use the Merkle Patricia verifier to retrieve the value from the proof. And you do have to do a little bit of encoding to make sure the mappings work there. So overall, I hope this has been a good example of how private voting works. We do have this running on testnet, and all the code is open source. So I think I'm going to wrap up here and say thank you very much for listening to me. And if you do have questions, you can either scan the QR code, or you can go to our GitHub, or you can get in contact with us on Telegram and Discord. So I know that I'm on Discord fairly routinely, and if you do have any questions, we'll be more than happy to help there. So I think thank you very much, everyone. I'm going to wrap up for now, and thanks, Will, for being on earlier. And I think that's all for now. So thanks, guys.